All right, welcome to navigation problems using vectors. There are other ways to solve navigation problems. Lots of times you can use law of sines and cosines, everything else, but this one is specifically using your x and y components of your vectors. So the first thing I want to go through and clarify is just the way that they can tell you what direction a ship is moving, or that you are walking, or a plane is traveling, etc. The first way is using something called a bearing. Now, a bearing is not going to be like the unit circle. What it does is you start from the north and then you go clockwise. So a bearing of 140, you start north. Keep in mind, I've already gone 90 degrees there. So I have 50 more degrees to go. So right here, that would be a bearing of 140. So keep in mind, that's 50. And then this right here would be 90 degrees. Now on the unit circle, this would actually be negative 50 degrees. Or if you wanted to think about it, 360 minus 50, because you're going that way, you could say 310 degrees. This would be the unit circle direction in that fourth quadrant, but the bearing would be 140. Okay, for this one, using your cardinal directions, northeast, southwest, you might see something like this, N40 west. So it just means that it's 40 degrees west of north. So we start at the north and we're going west. Remember, west is going to be towards the left. So we're going to go 40 west. Well, that kind of looks 40 degrees. There we go. So right here would be the 40 degrees. So it's in that second quadrant. If you're thinking about the unit circle though, for the unit circle in the second quadrant, that would be 90 plus 40. So that would be 130 degrees. So again, cardinal directions different from the unit circle directions. Okay, and then this last one here says 25 degrees east of south. So I start at south and then I'm going to go 25 east of south. So that's the 25 degrees there. And if you look here and think about, again, the unit circle, 0, 90, 180, 270, plus that 25 is 295 degrees on your unit circle. You could also go ahead and say negative 65 degrees. That would be fine as well. If you wanted to think about it from the 360 mark or from 0 going backwards, that's fine. But just to clarify, the directions we're going to be using today to calculate will be the unit circle, but we need to go ahead and figure out how to go back and forth between bearings and cardinal back to the unit circle directions. So something else we just need to review is how to find the components of vectors. So I drew this picture up here to the right, and it's just a triangle in that first quadrant. And so right here, if we go back to our sine, cosine, and tangent, if I think about the cosine of theta, it's adjacent over hypotenuse, so that would be Vx over, remember this is just the symbol for magnitude or like the length of that vector. And if I go ahead and cross multiply, you can see here that the x component would be the magnitude of the vector times cosine theta. Well, it's the same thing for sine. Sine, of course, would be opposite over the hypotenuse. And so right here, that would be the magnitude being in the denominator, cross multiply. And again, you get that the y component is the magnitude times the sine of theta. So let's go ahead and find the components in this example here. It says I have a vector with a magnitude of 6 at a bearing of 110. So this is a bearing. So we just learned, remember, this is from north and we go clockwise. So that's 90, and then I need to go another 20 to hit 110. So again, that would be the 90 part, that would be the 20. That makes the bearing of 110. But on the unit circle, this would either be, so this is 0 or 360. I can either look at this as 360 minus 20 or 0 minus 20. So theta would be either negative 20 or 340. It does not matter which one. They're the same coterminal angle. But now if I'm looking for the parts here, in the x direction, since this is in the fourth quadrant, our x values should be positive and our y values should be negative. So if I do 6 cosine of negative 20, and then for my y value, I'm going to do 6 sine of negative 20. And again, you can use 340 if you'd like to. Make sure you are in degree mode, but the x component would be around 5.64. I'm just rounding to the nearest hundredth. And for Vy, you would get negative 2.05. And that makes sense that, again, the x component's positive and the y component is negative. So if this were a right triangle, if I create this to be a right triangle and this has a length of 6 right here, this part would be the 5.64 and this would be the negative 2.05. So on the picture, that's where that fits in. For adding and subtracting vectors, you may have seen this in physics or maybe you've already talked about it in one of your math classes. When we add vectors, we're going to put them head to tail. So here I have vector A and I have vector B. If I'm going to add them, notice how I have A in the direction that it is, but then I start by putting B right here where A left off. And so the resultant of A plus B, this would be the starting point and this would be the ending point. And so I'm just going to kind of sketch that in here. This right here would be the direction and the magnitude of A plus B. So if I added the components of A and B, I would go ahead and get that resultant vector. Now let's go ahead and look at A minus B. So A minus B, again, I have A the way that it is, but notice that B is the same length, but it's the exact opposite direction. It's 180 away from where B goes. B looks like it's going somewhere in the second quadrant, whereas negative B would be going in the fourth quadrant. So A minus B would produce a resultant vector like so. That's just a little symbol for resultant. So that would be A minus B. And then, of course, the last one, let's go ahead and look at B minus A. And here you would start with B. So I'm starting here, and this is a positive B this way. But then notice how I'm going a negative A. And so my resultant, oops, that does not match up. There we go, much better. So that would be my resultant of B minus A. Notice that it actually is the same length of A minus B, except the opposite direction. And so that's something to think about, right? That those would have the same magnitude, but the exact opposite direction. But very different from the A plus B in this first example. So we do have to be careful about what is the order that I'm adding these vectors in when I start doing this navigation. What resultant am I looking for? All right, now we get to take all of these things that we just talked about and actually apply them in a problem. So here in example 1, I'm actually looking at a plane traveling from Ashbury to Belton, and it gives us the distance and the direction. And then also then it travels from Belton to Canterbury and again gives us the distance and the direction. So let's go ahead and just draw this out first until I figure out like what they're asking and all that jazz. So right here, if I am going from Ashbury to Belton, I made my little crosshairs here at the bottom left, you see. And I'm going to go 75 degrees east of north. So east of north, remember, I go north and I'm going 75 east of north. So if I'm looking at what directions these are, this would be the 75, which means, remember, that would be the, oh, not 25, 15 this way, right? Because that would have to add up to 90. Good, so there we go, and that's at 470 miles. Great. So now if I am going from Ashbury to Belton, that was Ashbury to Belton. Yeah, so let's put a little Ashbury to Belton here, good. And so now I'm traveling from Belton to Canterbury. I need to make new little crosshairs because it looks to me like we are adding these vectors up if I'm going from one to the next here. So now we're going at a bearing of 14 degrees. So if I go from north and then I just go clockwise 14, maybe it looks a little something like this, right? And then I'm going 300 miles that direction. So again, this would be the 14 degrees. So 90 minus 14 would be 76. That's important. I'm going to need to know that. And this is 300 miles. So if I were looking at a regular resultant of just A plus B, I would go from my starting to my ending and go this way, right? But it says I want Canterbury to Ashbury, so I actually want to travel backwards. All right. So if I think about my vectors, I know that if I have A this way and B this way, this one here would be A plus B, but it looks like I'm going the exact opposite direction. So we need to do A plus B, but then negate it. So therefore our distance will be the same, but obviously we will be going the opposite direction. All right, let's take this information and go ahead and set up a nice little chart. All right, so when I work these, I like to set up a little chart to help us stay organized. So we're going to have our vector, we're going to have the magnitude of the vector, the unit circle direction, right? Then the components, we're going to find the x component and the y component of each vector. So the first vector, let's go ahead and look at A right here. So the magnitude is 470 miles. Our unit circle direction, remember, is not the 75, it is the 15 degrees, because if I'm looking at this as being 0 degrees right here, it's at 15 degrees. Now, the magnitude of vector B here is 300, and again, the unit circle direction is not the 14, it is the 76. So now let's go through and we're going to calculate the x component and the y components. So for vector A, we have 470 cosine 15. And again, please double check in your calculator, make sure you know how to do this. But I'm just putting that in my calculator and rounding to the nearest hundredth. And then here for the y component, I got 121.64. Now let's go ahead and do B. For the x component, again, which should be smaller, it looks much smaller in the x direction, I did only get 72.58, and then in the y direction, I got 291.09. So now let's go ahead and make a new column, and we are going to find A plus B. Remember, that means not the actual magnitude of these, we're just adding up the components. So right here, we're going to add the x components. And for the x components, I got 526.57. And for the y components, I got 412.73. So we can see that both the x and the y components are positive if I'm looking at A plus B. But we know that we are going to be looking at the opposite of A plus B. So I want you to go ahead and think about I'm just negating the x direction and negating the y direction. So my resultant will actually have these values for the components, just the negative version, because I'm going in the opposite direction. Great, so if I have the x component and the y component, and again, if we want to kind of sketch this, again, it looks kind of like above there, right? So it's looking like so, where if I were to draw my triangle, this would be my negative 526.57. This would be my negative 412.73. I know there are some fancy formulas out there, but just go back and remember you're doing Pythagorean theorem if you're trying to find this magnitude right here. So just use Pythagorean theorem. So a squared plus b squared equals hypotenuse squared. You technically don't need the negatives in here because when you square it, we actually do get everything to be positive. And then once you find that, you're going to square root both sides. And so for the magnitude of the resultant, you get roughly 669.05 miles. So again, that's just going to be the length that the plane is going to travel from Canterbury to Ashton, right? And so that's the length or the distance between those two cities, but we need to know which direction I'm flying now. So in order to figure out the direction, we need to think back to our sine, cosine, tangent. So here is my theta right here, and I have the opposite and the adjacent. So I'm going to use tangent, but I'm going to use inverse tangent. So here I'm going to use the inverse tangent of my y component over my x component. And so right here, this is what I'm going to plug in my calculator. I'm going to do the negative 412, negative 412, not 4.112, 0.73 over negative 526.57. So do this in your calculator. And I got theta giving us something around 38.09 degrees. Wait a minute, 38.09 is in the first quadrant. Yes, you have to be smarter than your calculator. Inverse tangent only gives you things in the first and fourth quadrants. We now are in the third quadrant because x and y are both negative. So we need to go through and add 180 to this to get the actual direction that we would like to go. The 38.09 is the direction of a plus b, but it's not the direction of a minus b. If you wanted to, you could fill this out. This is where technically the 38.09 degrees goes. And then when you go through and add the 180, we are going to be in the direction of 218.09. So our direction is roughly 218 degrees, 0.09. Now let's talk about what that means as a bearing. So in this picture above, we can figure out that this is where that 38.09 would be, right? But if I'm looking at it as a bearing and here's my north, I need to go all the way around this way, correct? So I actually need to go through and say, okay, well, that's 90, and then figure out what this part is right here by taking 90 minus that 38.09. which is just 51.91. When I add that to the other 180, I get that this would be a bearing of 231.91 degrees. So depending on how they would want you to answer, you can give them the unit circle direction, or you can go ahead and convert that over to what it would be as a bearing. Yay! So again, anytime you're able to break this into components, you can figure out where your resultant vector would be. All right, let's go ahead and look at example 2. So plane A leaves the airport in Austin at 2:10 p.m. It's traveling at 510 miles per hour at a bearing of 290. All right, and plane B leaves the airport at 2:15, traveling 580 miles per hour at a bearing of 35. So this is a little different because it's not like I'm adding these two planes together. These planes are traveling separate, both from the same position. So it's a little different with the way that we are going to draw these. Because then it goes through and says, hey, at 3 p.m., how far apart are the two planes? And at what bearing would plane A need to fly in order to reach B? So we're looking at a couple different things. First things first, if I know that I left at 2:10 and I'm traveling 510 miles per hour, I need to find the magnitude of A first. So remember, distance is just going to be rate times time. So I'm 510 miles per hour, and 2:10 to 3 o'clock is going to be 50 minutes, or 50 out of 60 minutes, or 5/6 of an hour. So when I go through and multiply this, I get 525 miles since it left the airport, and it's traveling at a bearing of 290. Ooh, bearing. Okay, so bearing starts north and goes clockwise. So 90, 180, 270, and I need to go 20 more degrees. All right, there we go. That's plane A, or vector A, for us. Now let's go through and find the magnitude of B, and we'll go ahead and draw the direction as well. So again, rate times time. We know that this one is traveling at 580 miles per hour. And 2:15 to 3 o'clock is 45 minutes out of those 60 minutes, or you can multiply by 3/4. And we get that it is 435 miles now from the airport. Now, at a bearing of 35 means it's going boop, just kind of like that far. So there we go. So there's your bearing of 35 degrees here. And it's a 435 miles. So here is our lovely picture, but notice we are not putting these vectors head to tail. So if I have vector A right here and I have vector B right here, I need to figure out what combination of A plus B, A minus B, B minus A, etc., would I need in order to go from plane A to plane B. I need to find this as my resultant. So let's look at a combination of A plus B, A minus B, etc. So I know you've already guessed that A plus B is not what it's going to look like, but let's draw it anyway. So this is A plus B, so the resultant would look like this. Obviously, not the picture that we have. Great. So let's try A minus B. So if I do A minus B, I start with A this way, but then negative B would be the opposite direction, so that would be negative B, and my resultant would be from here to here. Ooh, so close. That kind of looks the same direction, but quite the opposite, right? So maybe the last one we try, instead of A minus B, let's try B minus A. So if I have B minus A, oops, I have, start here, there's a lovely B, but instead of going, off to the upper left, I'm going to go to the bottom right, the opposite direction of A, so this is minus A. And you can see here now that that resultant is the one that we want to go from plane A to plane B. So we will be using our chart, but then finding B minus A. So in our chart, we're still looking at the same things. We want to look at vector A and B, the magnitude, the direction, unit circle direction. We're going to find the x components, the y components, but then we're going to look at B minus A and not A plus B. So first things first, we know the magnitude of A is going to be 425. And then think about what the unit circle direction is. If this is 180 degrees over here, it looks to me like it's 20 degrees a little above that. So that would be 160 degrees on the unit circle. For B, you are looking at 435 degrees, but notice this is the 35 degrees, and so 90 minus 35 over here would be the 55 degrees. So if this is 0 degrees on the unit circle, 55 degrees would be the unit circle direction. So again, just as a reminder, to find the x components, we're going to do v cosine. To find the y, we're going to do v sine. You can go ahead and pause it and check these answers yourself, but I'm just going to go ahead and fill them in. So hopefully when you went ahead and put this in your calculator, you got the same values I'm getting for my x and y components. It makes sense that for vector A, that's in the second quadrant, my x is negative, my y is positive. And then for vector B, that's in the first quadrant, my x and y are both positive. Now here's the tricky part here. Watch your subtracting negative signs. We're going to do B minus A. So remember that's 249 minus the negative 399. So both the x and y component now are positive, and that looks to be correct with the way that our resultant is drawn. So I'm just going to look at just the resultant here in a new crosshairs, like a new origin here. And I just want to remind you that, again, if this is our resultant, the x value here is this 648.88, and the y value is the 210.97. So find the magnitude, and you're just looking at Pythagorean theorem. And then to find theta, we're going to use that inverse of the y over x, the inverse tangent. So let's go ahead and calculate those. So for the magnitude of our resultant, it will just be, again, you don't need a fancy formula, but it is this formula if you really want it. It's just like your x component and your y component, and then square rooted. So go ahead and we're going to substitute in the x and y components. And when I calculate that, I'm getting roughly 682.31 miles. So again, that's just the distance that point A is from point B at that 3 o'clock time period. So that's the distance there. And if everything was frozen in time and now plane A is going to travel to plane B, we need the direction. So again, do that inverse tangent and make sure you have the y component over the x component. And I'm getting roughly 18.5 0.01 degrees. And for this problem, that actually makes sense because I am in the first quadrant. So this is the correct direction on the unit circle. Again, if you were going to change that to a bearing, you need to go ahead and take the 18.09 away from 90. And I'm getting 71.99 degrees. So this would be if you're giving the direction as a bearing. So a bearing of this, but that's not the same thing as the unit circle. So it just depends what they are asking for. Love it. All right, let's look at our last example. And I'm actually just going to go ahead and kind of get you started here. And then I'm going to put the answer in the comment section here. So right here, who doesn't love a good treasure hunt? All right. So it looks like the treasure map says we're going to start at the big rock and take 50 paces at a bearing of 100. And then we're going to reach a pond and then turn to a bearing of 220 and walk 70 paces till I hit a palm tree. And then lastly, we're going to walk 90 paces at a bearing of 260 degrees in order to reach the treasure. Hey, it looks like we have 3 vectors here. Do not be scared. You're just going to do the same chart, except you're going to have the A, the B, and the C. So when we're working with these, though, let's see what they're asking for at the end. So to eliminate all of this walking, how many paces and at what bearing should you walk directly from the big rock to the treasure? So it looks here like this is going to be your start, and this right here is going to be your ending place. And guess what, folks? That means you're just going to be adding up these 3 vectors. So again, set up your chart. I got you started here a little, but I want you to be able to fill out your direction in the unit circle direction using those bearings, and then find your components and find your A plus B plus your C. Check out the answers in the comment section. And as always, thank you for watching. Go ahead, you can check out my website. You can check out any other videos on YouTube from Math Tutors ATX. Thank you.